Okay, welcome to physics today. Today we're going to talk about mixed constant and acceleration problems. So there are problems when we have a constant speed portion and an acceleration portion. So let's just draw one because it's always easier to do these problems when you draw them. So let's say we have a person that is going down a hill coasting and they started from rest. So we're starting from a 0 meter per second at the top and we're coasting down, and let's say our acceleration is going to be 2 meters per second squared as they go down this hill. And let's say they go down this hill for 9 seconds. Okay? And then once they get down here, they're going to coast for, let's say, they coast for about another minute. So time is 1.0 minutes. Okay? And so this is our problem. So first thing you want to do is draw a picture of it. So let's say we have this picture here. We have this person on this bicycle, and they're coasting down, and they're going to come down here. They're going to coast along here as well. So we have this situation. And so we want to know that our problem is going to be in two parts. So it's going to be an acceleration part, and it's going to be a constant speed part. So we need to treat each part differently from each other. So how are we going to do this? Well, we're going to treat this side with V equals d over t equation. So we need to find these pieces. But this side is acceleration. So we're going to need VF, VI, A, D, and T for our equations. Now we know VI, we started off at 0 meters per second. Okay? And so we need to figure out this problem. So we need to figure out, well, what's the speed down here? Because that's going to be the speed over here that we can plug in this equation. So there's always information here that you can use over here, but not everything. Like 9 seconds is how long they go downhill, but we're only going to coast for 1 minute more. So we can't use this time over here, but we can use the speed because that'll be the speed at the bottom of the hill. So we want to figure out how far they'll go. So the whole idea is what's the greatest, so if my question is what's the total distance? Well, to do that, I need to find, first of all, the distance here. Okay? So we can do that. We have no VF. So we have no VF. So to solve for that, we got to find an equation that has no VF in it. So that's D equals VIT plus 1/2 AT squared. So D equals VIT plus 1/2 AT squared. So we plug our numbers in, and this is going to be 0 because 0 times time, 9, is going to fall away. So I'm just going to ignore this first part of this equation and say D equals just this half of the equation in this scenario. So we have 1/2, we have 2 meters per second squared, and we have t squared, which is 9 seconds squared. And so if I figure this out, half of 2 is 1. 9 times 9, 9 squared is 81. So 81 times 1 is 81. And my distance, since these are squared units, we cancel out here, be 81 meters. So D, on this side of the problem, is 81 meters. Okay? So I've now just figured out the total distance, part of the total distance, but not all of it. So now I go over to this side of the equation, and I need to find these numbers. Now I not have time, but I can't use minutes. I got to use seconds. So I'm going to take and convert that really quick to seconds, and I know it's 60 seconds 1 minute, so it's 60 seconds is going to coast at constant speed. But I need to know the speed that it's going. Well, I don't know that because that would be the final speed at the bottom of this hill. So I actually have to go back here and solve for part of this problem right here. So what is the final speed? So let's find that. So I'm going to do a little problem over here again to solve and figure out this speed that it is coasting along at this time. So VF, okay, is what I want to find. And so I'm going to ignore my D equation. my D information, because I already have it here, but I'm not worried about it, is VF, or VI, plus A times T. So that's an equation that has no D in it. So I'm going to assume I have no D. And so then I go on, and then we have VF, so it's 0, because that's the speed it starts off with, plus acceleration, which is 2 meters per second squared, times 9 seconds. Seconds cancel out, and so I get meter per second. And so the speed will be 18 meters per second. So the speed that is going when it's coasting is 18 meters per second. Now I can simply find distance by V equals D over T. Solving for the D, I would multiply both sides by T. So I would just basically take my 18 meters per second and multiply it by my time of 60 seconds. And so on that, we have 18 times 60, and that gives me 1,080 meters. So to find the total distance, which was my goal, is I would add this number and this number. And so those together would give me distance total. So we have 1,080 plus 80 more. I'm going to go 1,160 meters total in this problem. So there we did a acceleration and a constant velocity one. And now it can change around. You might end up having somebody traveling at constant speed in a car, and then what they may do is they may then hit a hill and then coast up the hill and slow down to stop. So VF is 0, so then you would have to do the constant speed equation first and then the deceleration second. So that's why I recommend you draw the problem and figure it out with the drawing. Is acceleration first, then constant speed, or is it constant speed, then deceleration or an acceleration in that direction? So that is how I would approach a problem that is mixed, okay? Thank you very much, and you have a great day. Blessings.